Hey guys, welcome to my new project. It is a molecule simulation. I have done this intro like 7 times because there's so many issues with my computer. Anyway, so basically the molecule simulation that I am working on is, well, it's something, certainly something. It is mostly only like collision, so it's more like a gas. There's no liquid solids or anything like that. It only simulates reactions mostly. So yeah, let's get started. I'm first going to show you some acids and bases reacting with each other, and then I'll show you some other reactions, like decomposition reactions and other ones. For our first reaction, we are going to do sodium hydroxide and hydrochloric acid, and this reaction will produce water, and it will also produce, let's see here, it will produce salt, so NaCl. Let's see. Now, right now, in the lab, we did not have any sodium hydroxide, but we did have potassium hydroxide, and it's essentially the same reaction. So, let's get started. Now, eventually they'll slow down, so I'm gonna have to use this. But yeah, so what you're gonna see is that basically they separate into ions, and then those ions will react, and eventually just form water, as you can see at the end here. So basically, it just forms salt and water, just like I said with the reaction. So it's very visually understanding. Uh, it's not just letters and numbers and stuff. It's more like visually logical. So yeah, our next reaction is going to be nitric acid, which is HNO3, and calcium hydroxide, which is KOH. And basically the reaction will produce water, of course, because they neutralize. And of course, it will form calcium nitrate. So we should see that reaction. Uh, Something to note is that you might see the calcium nitrate decomposing. Alright, let's do the reaction. We should see the reaction taking place almost immediately as soon as the nitrate. I would literally just think of nitric acid as liquid nitrate, basically. Because it's basically just, because it also decomposes. Oh, almost combined it to form water. Okay, let's speed it up a bit. Oh, you got a hydronium ion now. It's also breaking apart to form nitrogen dioxide gas, which should not be happening because the simulation isn't really built realistically with temperatures. I do not know what the hell is going on. Something weird is happening. But yeah, that was the reaction. It also produced oxygen gas somehow. Yeah. Nitric acid is an oxidizer. I forgot to mention that because kicking off oxygens. All right, let's do some decomposition reactions this time. So one thing that I recently learned about acids is that they don't actually look like this. In fact, they don't look like that at all. They look like this. So basically, here we have a negatively charged ion, and here we got a positively charged ion. I don't know why this took me so long to realize. I just thought it was very confusing. But yeah, that's just how it works, I guess. So they just do that in solution. Anyway, so what will happen is that this is a decomposition reaction. So what will happen is that one of these oxygens will be kicked off, and the byproduct of this reaction is the fact that HNO3 will decompose into nitrogen dioxide and a oxygen. And these will go on to form oxygen molecules or react with other things, and this is why it's also an oxidizer. So, there's that. Dear God, I was just experimenting. It was actually working pretty well. Alright, Let's show you the decomposition reaction. Actually, maybe it's a bit easier to watch with only like one or two. So, you'll see that they separate into their ions, of course, which are negatively and positively charged. I don't know why that one's not breaking apart. Oh, and yeah, there you just got it. Oh, they almost just did it. So you can see that they break apart into nitrogen dioxide, and yeah. Wait, did I... Hold on. I think I made the nitrogen molecule wrong. Those aren't supposed to be... Oh, well, let's just... Don't care about that shit. No, but look, it works. See? And eventually, yeah, oxygen gas. So there's our first one. Now, let's move on to the next one, which I think you may have heard of. I'm sure we are all familiar with H2O. It's the most popular molecule. It's drinkable. It is the best molecule. It is polar. It is perfect in all ways. But you may not know about its more rare brother. Hydrogen peroxide is, well, just water but with an extra oxygen, and it basically just looks like this instead. It is a weird looking molecule. Water, as an example, just looks like this. So, yeah. I think I used to draw it like that when I was younger, but that's wrong, so don't do that. Anyway, hydrogen peroxide decomposes into water and a radical oxygen. So, the reason is because I guess it's just like molecules just don't like having single bonds, and they'd rather not bond with like more, and the molecule would rather be more simple. So it just becomes a more simple molecule. And so we'll see that right now. So I have about 16 H2O2 molecules, which, because they'll be giving off one each, means that all of these, when they combine into oxygen gas molecules, they'll get about 4 oxygen gas molecules out of these decompositions. So we'll see them breaking apart right now. You just saw one happen there. And of course this isn't an oxidizer because it releases that. So let's just watch it for a while. Just gonna remove that so you don't have to look at that. It's more relaxing. Or actually, maybe even just remove this. There. Alright, so the reaction is practically almost finished. I think I know what mistake I have made. I don't think I did the math wrong, but it's actually gonna form 8, isn't it? So if we speed this up. One, two, three, four, five, six, 7. Yeah, there's 8. I forgot. You just divide by 2. Jesus, I'm stupid. Alright. It's just literally 16 divided by 2. Oh god. Oh well. Let's show you some other really cool reactions. One pretty cool reaction is you might have been wondering, how is ammonia a base, right? There's no way that it can split up into OH groups, right? Well, you see, ammonia by itself is not a base until it reacts with water, in which case it does this. Did you see that? Right over here. And so why this happens is because oxygen is more reactive and electron greedy, or electron affinitive as they call it, than nitrogen is. So it just basically steals an electron from nitrogen and kicks off a hydrogen because it doesn't need Joe anymore because it got an electron. And that free hydrogen atom goes to the ammonia, or actually it's not really free for that long because it just, it just steals it immediately. And so basically it does this. That's just all. Pretty cool. And so it's actually the reaction between water and ammonia that does form the base, and it creates a ammonium ion, which I had to Google up in one of the outtakes because I did not know what it was called. But yeah, pretty cool. That was something I didn't know. I was confused about that. Another very similar reaction is the reaction between water and lithium, where oxygen, again, just steals an electron from lithium, and so lithium becomes a positively charged ion, and of course, the water molecule then kicks off a hydrogen atom because of that, but this time, it cannot bond with another atom, because lithium doesn't want an extra electron. So what happens is that there's just a bunch of free radical hydrogen atoms in solution, which then combine to form hydrogen gas. So we'll get to see that very quickly here. Oh, you see that? Hydrogen gas, H2. More. That's pretty cool. So yeah, that's pretty cool. So that's the reason why if you drop something like lithium in water, it will start combusting, because this reaction generates a lot of heat because it releases a lot of energy because, molecules are getting simpler, new bonds are being created, and because of that, that has to release energy. Just that's how I think of it. Anyway, that heat, combined with the very flammable gas and in a oxygen atmosphere, causes the hydrogen to burn, and can even cause the lithium to burn and form oxides, which creates a nice little flame color. And of course, the the lithium hydroxide makes it also turn the water basic. So yeah, and the lower down on the periodic table you go, so from lithium to sodium to potassium down to rubidium and then cesium, francium, all of those, as they get bigger, they have a higher chance of just reacting because they're larger, right? And because they take up more space. And also, their electrons are weaker held to the nucleus because they're further away from the nucleus, which means that their electrons are they can just go much easier. They're way easier convinced, meaning that they're more reactive, and so it's just much faster. And basically, the lower down on the periodic table you go there, it becomes more and more and more reactive, meaning that lithium is less reactive than sodium, and sodium is already reactive enough to start burning. Meanwhile, lithium just fizzes a little, and if you go down, potassium just straight up like explodes. Cesium, rubidium is at the point where on exposure to air it could be a hazard. Cesium, on exposure to air, it can start melting and it can combust and burn. In contact with air, it starts smoking. So yeah, they just get more reactive. Let's see some more reactions. Kind of went on a tangent there. Again. One of my favorite reactions is, in this simulation at least, is hydrochloric acid and magnesium, where the magnesium will donate its electrons to the chlorine, and because the chlorine doesn't need the hydrogen anymore, and because it gets overcharged, it will give the excess electrons to the hydrogen, which creates free radicals, and then boom, hydrogen gas. Let's see that happening. So you can see this one is plus -2 positively charged. It just is not, and that's the product of that reaction, and it is moving about, and eventually that will combine and form a hydrogen gas molecule. So yeah, and what's left is magnesium chloride. Magnesium 2 chloride, I think it's called, because it's a +2 ion. So that's pretty cool. Yeah. And of course, since hydrogen is flammable, you can create some cool stuff with it. Add some oxygen, see what goes on. Should see a reaction. Oh, look, water. What the hell just happened? What is going on with that water molecule? You see that? What? Oh, I see what's happening. It's breaking apart. Yep, and it's unbreaking. What the hell? Okay, I don't know. That's just weird. Anyway, let's see what happens now. I'd say like this is one of the coolest reactions in the game. Basically, if you press numbers on the keyboard, you can spawn in different molecules. So here we have these molecules, and we got nitric acid, we got methane. Oh yeah, I forgot to show that reaction. I'll do it later. It's not really the coolest though. Oh yeah, there's the potassium. We can try potassium on water this time. It's a bit more reactive, so we should see more of a reaction. 1, 2, 3, 4, 5, 6, 7, 8. And then we'll have 1, 2, 3, 4, 5, 6, 7, 8. Since it's an even number, it should create some. Yeah, look, that's reacting almost immediately. Compared to the lithium, I think I made it to react more readily, more faster than lithium, so it's a bit accurate. So yeah, that's cool. Now we got some potassium hydroxide going here. Add an oxygen molecule. Let's see it going for the attack. Oh, it just happened. Oh, did you see that? Oh, that was so cool. I'm so proud of this. I can't believe that I made this. Can't believe that a dumbass made this. Okay, I'm not actually stupid, but yeah, I just thought I'd just make it. And if you press letters on the keyboard, you get example loadings, so you can load up examples like this one. You can load up this reaction, which is nitrogen and lithium reaction, where the lithium is donating its electrons to the nitrogen. So even though that nitrogen is considered a what is it called? It's called it's just called unreactive gas or something like that. Something like that. In unreactive gas, lithium just like it's so reactive that it will or like how do you explain it? It just will give off its electrons. So yeah. Even though I just said that other elements are more, ignore that. It's just the fact that nitrogen can just take. So yeah. So that's pretty cool. Let's check out another one. There's that one again, lithium. Yeah, that one's totally slower. Look at that. I feel like that one was totally slower than the one I made. This is, I don't even know what the hell that is. Here we got piranha solution mixed with, what is that, chlorine? No, that's piranha solution. Kind of want to see what it will do to methane. See if we'll eat it. What do you think will happen to methane? I think it'll die. Keep watching it. I'm sure it'll, like, disappear in a matter of seconds here. Oh! Oh no. I'm just gonna redo that. Let's add another methane. Or actually, do that. Add methane now. Time lapse. I know it's not gonna take that long before something happens. Oh, what just happened? What? Hold on, where the hell did... Oh no, that makes sense. Never mind. I thought that I thought it was 2 carbon atoms. I thought something just got deleted. Some kind of glitch. No, sometimes I'm just bad at chemistry, I guess. This is bouncing about. Man, on a molecular scale, this is taking 100 years. Okay, I'll just be quiet. Alright. I think it's completed now. You can watch it eat more methane if you want. Let's do that. Oh yeah, I'll put the link in the I'll put a link in the description to get this. It's on Scratch, if you were wondering. Seems to do quite well with that stuff. I think I need to add some hydrogen peroxide, some more. Boom! Just ate all of it. We got benzene reaction. Well, actually, two. It's a lot of carbon dioxide, actually. What did I just do? Let's check out... Maybe that was all of them. Oh, here we have, whatever the hell this is. It seems to just be a solution of some hydrochloric acid and sodium in its, +1 form. And a +1 ion. See what it does to, I don't know, some other random molecule. Certainly breaks apart sodium bicarbonate into that. Let's try adding a few other molecules. It's probably not going to do anything to methane. Well, I mean the nitric acid will, as we see here. broke it apart. Add another nitric acid. If I add 2 more nitric acids, it'll fully be able to decompose the methane. As we'll see. Calculated in my head. So it should be correct. It's all the way up here now. What the? Whoa! It's moving about like crazy. Where's the methane now? Oh, there it is. Whoa. Oh, can't see up there. Oh, there. I think that will help. It's still... Whoa. Right now this is just me having fun. This is not really me showing off anymore. Well, I mean, I guess it is, if you want to play it. Oh. That just happened. There we go. That was cool. Alright, I think I'm done. That's gonna be it for this video. If you like this, then make sure to subscribe for more. And I'll see you next time when I got something else cool that I want to show you. Alright, bye bye.